So guys, as you can see, we are only gonna use a pin number B.F6, that is only one pin running tons of LEDs. See, it is running multiple LEDs on the same pin using one pin. We have external voltage source for the LEDs and another source powering up the PIC, while the ground of the external source is common with the normal source of the PIC. In this way, our connection is completed. So we can simply, you have to select a transistor, and if your transistor can overcome the load as shown in the tutorial, then your one LED can run the load using that transistor. So let me show you some math. See that TIP122 can give maximum 5 ampere of current. So for 100 LED, we only needed 1000 milliampere. So 1 ampere, so 5 ampere is greater than 1 ampere, so this transistor will work, and as you can see, it is working. So few LEDs only, for example, I don't have the time to make 100 LEDs here, so you can go up to 500 LEDs as well with just one TIP122. So that's all. Hello guys, welcome to learning microcontrollers. In this video, I will show you how you can connect multiple LEDs on single pin of a PIC16F877A microcontroller. So let's get started. So guys, this over here is our PIC16F877A microcontroller. So let me show you a scenario. Suppose we have 7 LEDs, and for 7 LEDs we will need 7 220 ohm resistor to limit the current, and then as you know, the longer pin of the each LED is the power and the shorter pin is the ground. And let me connect the one end of the longer pin of all the LEDs to the one end of the 220 ohm resistor like this. Now guys, from the other end, I common them, I send them to a single pin. Now here in our case, we only have 7 LEDs. But in case you are like making a cube or some fancy light, and there are like thousands of LEDs, and you need to connect 100 LEDs to one pin. And then do you think this LED will be able to power up the whole circuit? I don't think so, because PIC16F877A port B can only provide up to 200 milliampere of current, while this LED, the red LED, probably may take up to 10 milliampere each LED at 5 volts. So it will be like 1000 LEDs or 100 LEDs means up to 1 ampere of current, and this pin cannot provide that. So in that case, your circuit will not work. So how to do that? How to connect like 100 LEDs on single pin? Right now, let me show you. If you connect 7 LEDs, it will simply go like this. But if you have like 100 LEDs, you will simply start commoning them and until you get to the 100. And then when you switch into this pin, then do you think it's going to work? And 7 LEDs will work. But if there are 1000 LEDs or 100 LEDs, they will not work because PIC pin will not be able to provide that much current. Now how to get over this problem? Before we continue, let me first run this circuit so you know that these 7 LEDs can work, because 7 LEDs are up to like 70 milliampere of current, and PIC16F877A port B can provide 200 milliampere. So let's get to the MikroC for PIC and let's write a code and then burn it into the microcontroller. So guys, this over here is the MikroC for PIC. Let me zoom in. Let's write a small code for this circuit. So clear the things up. Okay, I go here, go to the file, new project, click on next, write the name, just test code, multi tutorial here, and the microcontroller is a PIC16F877A. Crystal I have is 20 megahertz, and I click on next and finish. Now before you do anything else, first of all save your work. For that, press Ctrl S. Okay, like this window pops up. Save it. Okay, I have selected the port B, pin number 6, so I write this B.F6 equals to 0. Pin has been declared output. Initially, the LED at this pin must be off, so port B.F6 equals to 0, and give some initialization delay, not necessary, but I suggest you give it in the one-time loop, like this, and I make it like 100. So I forgot to tell you the version of MikroC I am using is 7.2.0. You may use a higher version as well. And now let's get to the forever loop. Write down while 1. Forever loop starts here and ends here. And inside it, just blink the LED. I copy this, paste it here, give some initialization delay. Oh, sorry, delay, like it will be the actual delay of a half a second. LED is on for half a second, and then it will turn off for half a second, like this. And in this cycle, it's off. Now that's a very simple code. Let's build it and check for errors. No errors, successfully built. Okay, let's get to the Picket3 programmer tool. Here it is. Go to the file, import hex file. This is the file. Click on write. Okay, the new file is being written. Let's get to the hardware and see what happens. So this over here is the hardware. Okay. Okay, this is the PIC16F877A, and these are the 7 LEDs, and you can see that this wire, okay, let me power up the circuit using the PIC3 programmer tool. Click on. Okay, you can see that it can power up the 7 LEDs, see, and only one pin. This is the wire connected to the pin number B.F6, and coming to this circuit over here is powering up the LEDs, see. So 7 LEDs can easily be powered up using one pin because it's 70 milliampere of current. Now I don't have thousands of LEDs or 100 LEDs to show you that it will not go work if you go up to 20 LEDs. Like if you have more than 20 LEDs, then one pin will not be able to power them up. So in that case we will need a solution. So let's continue with the presentation and let me show you what is the problem and what is the solution. So this is where we continue. Okay, now guys, what's the problem is that suppose we have 100 LEDs on one pin, then each 5 mm LED at 5 volt draw 10 milliampere of current. That is for the red LED. Like for the red LED, it is normally taken that it draws like 20 milliampere of current at 2 volts. So at 5 volt with a resistor of 220 ohm, it may take up to an 8 to 10 milliampere of current per LED. So suppose we have 100 LEDs, then 10 into 100 it will be 1000 milliampere of current, and 1000 milliampere is equal to 1 ampere of current. So this is a huge current, while our pin can not provide more than 200 milliampere in the best case, like whole port. This is not the pin, it is a port. Then guys, this is the problem. Now I want to connect 100 LEDs. How I will do that? Now to overcome this issue, we need a transistor. There may be other solutions like ULN 2003, motor driver or H-bridge, but in the end these all are basically a transistor. So we can simply use a transistor to overcome this issue. Now first of all we need to select a transistor. Now how do we select a transistor? Now I'm going to select a transistor for 100 milliampere. The most cheapest and easily available everywhere is a BC547 transistor, easily available in the market. So first let's get started with this. So first of all we go to our internet and we check for the data sheet of BC547. So I go to the internet and let me zoom in so you guys can see better. Okay, just write down here BC547 transistor data sheet. So always go to the data sheet because information provided here there on the internet is not mostly up to the mark. So this is the data sheet here, BC547, Fairchild BC547. They will have the same specs, little bit of difference. Now we need to see the current. So here it is. See, I see that is a collector current. This is the current we need to know is 100 milliampere. So BC547 can handle maximum of 100 milliampere. So now what's the issue? So now we know that from the data sheet that BC547 can handle only 100 milliampere. So this means that if BC547 max current is 100 milliampere, while we need to connect 100 LEDs and they will draw up to 1000 milliampere. So we cannot use the BC547, we need some other transistor. Now we go for another very common and easily available transistor known as the TIP122. So for the TIP122, let's again do the same process. Let's get to the internet and we write, let me zoom in so you guys can see better. I will share the link to this data sheet as well. And now go for TIP122 data sheet. Here it is. Okay, this opens up. Now here you need to get the data sheet. Okay, here is the data sheet. Okay, it's a TIP122 data sheet. It's a Darlington transistor and it do have good current characteristic. Now here it is our collector current. Now IC is the collector current. See, it's now 5 ampere. That's great. So 5 ampere. Now let's see. Now the TIP122 can offer us 5 ampere of current. So let's get back and check. Okay. Now TIP122 max current is 5 ampere. 5 ampere is greater than 1000 milliampere. That is our requirement for 100 LEDs. So it means that 5 ampere is greater than 1000 milliampere or 1 ampere, then we can use this transistor. And moreover, this transistor can support up to 500 LEDs because it can supply 5 ampere current, and 5 ampere means 5000 milliampere, and each LED takes 10 milliampere. So it means that we can run up to 500 LEDs using this transistor. Now that's great. Now let's connect this transistor on the Proteus. So let me zoom in so you guys can see better. First of all, go to the left. Here it's P. I'm going to use a Proteus because I don't have 100 LEDs. So Proteus will allow you to easily understand the schematics. So write down PIC16F877A. That's what we're going to need here. So this is the microcontroller. Place it anywhere you prefer. Again, write down here TIP122 NPN transistor. Here you go. It's here. See, here too it says it's 5 ampere. Place it here. Now we take some LEDs. Go back, write down LED. Here we have LEDs. Go down and take some proper LEDs. Okay, LED. Okay, you will have LEDs here. Go down, down, down. What I had written here? LED. No, this is not the LED. Okay, look for the LEDs. Here we go. These are the LEDs. You can use any of these, blue, green, red, or whatever you prefer. So I'm going to use the red one. Okay, this one. Okay, the red LED. Here we go. The red LED. I take like 1, 2, 3, 4, 5, 6, 7, 8. And you can go on up to 100 LED, 500 LEDs with this transistor. On the simulation it will work. I am just showing you the schematics. Now guys, for this you will need a higher supply. So we take another supply. Just go here, write down battery, or you can just take the other voltage source. Go to here, and there is a power here. You will need to connect a supply to the collector here like this. And this will be the additional supply for these LEDs. You will not take the supply of the PIC here, just an additional 5 volt supply which can easily support 5 ampere of current. While PIC will have the same supply, it doesn't matter, you can use a diode. Now for this pin, it will go to your microcontroller, and for that we will need here something called resistor. Okay, write down resistor. Okay, this is the resistor here. Just connect it here on the base. Any value will do. 10K is fine. Connect it to the pin number B6 like this. And for the ground, just use a ground at the bottom. Here you go. This is the ground. Connect it here. Common all the LEDs like this as shown. You will common all the 100 LEDs to this ground like this. This will be the simple parallel connection. Just like this. Connect all the LEDs to the ground in this way. Okay, connect them. No matter how many LEDs you have, maximum you can have 500 LEDs with the TIP122 transistor. Now this end will go to the upper end of your LED like this. Connect them together like this. All the LEDs like this. Now this is how you will connect a transistor. No matter, it might be the BC547, any NPN transistor, depending upon the current requirement. You will check on the internet what is the current requirement that you need for your load, and then what you are going to do is that you will check the model of the transistor. Whichever is suitable, just take the NPN one, and for the NPN one you always have the base, emitter and collector. That's all. Base will go to your microcontroller pin with a resistor, emitter will go to the LEDs positive, and collector will go to the positive of the external supply. That's all. Now this is how you are going to connect it. Now what I do is that I burn a code, the code we just wrote, the test code. Okay, the crystal I have is 20 megahertz as configured in the MikroC, and this is the test code. Let me open the test code. Okay, this is the test code here. Okay, now I run the simulation. See, all the LEDs are blinking. So in this way you connect a transistor. I'm just showing you how you can connect a transistor. So that's how you are going to connect a transistor. If you want to use one pin to run a big load or like hundreds of LEDs, you can even go thousands of LEDs depending upon the current requirement, and then you will select a TIP 122 or any transistor which can overcome that current requirement. Then you will use an external source. This collector current will come from the external source. Okay, that's all. And then your base will go to your microcontroller like this. It's simple as that. So to give you a better idea how the external source is connected, let me show you another example. I take a battery. Okay, a battery. Okay, this will do fine, or this one will also do fine. Okay, we take this battery. Okay, now here use a galvanometer to check which side is positive or negative. DC voltmeter. You can use it like this. This will tell me which side is positive or negative if I connect it wrongly. So what I am trying to show you is that this positive will go to the positive like this, and the negative will go to the same common ground of the circuit like this. Now in this way your external source is connected, and the voltage for the LEDs is 5 volt. If you give 9 volt, it will get burned. So your battery will be 5 volt, or whatever the external adapter you are using, make it 5 like this. Now run the simulation. See, it's giving 5 volt, and see again it is working. So the external source positive will go here. See, you will not give it to the PIC. See that the positive is going here, 5 volt. It is going here. It might be the adapter, whatever it is, and the PIC supply coming from another 5 volt source will not be interlinked with this. If you want to connect it here, then you have to use an isolator, or you may use the other supply, or you may use a converter. That will also do fine. So in this way you can use one pin to run a big load using a transistor. So guys, I hope you learned something from this video. Thank you very much for your time, and have a nice day. And if you have any questions, please do ask me in the comment.